I'm very excited to be here. I came all the way from Hawaii, where I work for University of Hawaii now, of all places. I live in Honolulu. I did my PhD at University of Pittsburgh, and a big part of that was, my dissertation was rethinking the old copper complex, using a new line of evidence to understand when and how intense the old copper industry was up here. So we're going to look at some of that new evidence, and it's new evidence to, I think, the public, but a lot of this has been published already. And I, just like Bob mentioned, have a book that came out on this a year ago, but I want to get us up to speed on the old copper complex. And Bob, you did a great job introducing us to the subject, so I'm just going to keep it short on the background. But broadly speaking, we call the old copper complex, or the old copper culture, which is like a more narrow geographic definition. Basically, what we're saying when we say old copper complex is the use of native copper 8,500 years ago to about 3,000 years ago. It seems to have emerged about 10,000 years ago, and we know it was mined from the bedrock. It's not one culture, let's say, but definitely existed over thousands of years. So it was, that's why culture is sort of a tough word. Complex is better because it's a large geographic range over thousands of years, encompassing lots of hunter-gatherer cultures that made distinct stone tools, but they were connected by a tradition of heavy copper tool technology, big copper utilitarian tools. And as Bob mentioned as well, these, if you want to study the old copper complex, where would you want to go? I think the first thing when I was doing this research was, let's go to the mines where they got the copper. That must be the concentration of all the stuff we can, or a lot of things we could learn. And as I dove into it, I found out Whittlesley, in 1862, he drew that map. It was published by the Smithsonian in 1863. He published the location of the mines. And so I used that as the initial guidance to studying how and when these mines were created. This rock that's exposed with copper, though, is found throughout the Lake Superior region in certain places, one being the Keweenaw and Isle Royal. And so if you actually look at this bottom left-hand map, the orange are places where the copper-bearing rock would have been exposed at the surface. So there would have been no need to remove soil in those orange regions. And so those are the places that, it turns out, Whittlesley found out when I superimposed the maps together in GIS. Whittlesley showed that those exposures were indeed where the mines were located. And that makes sense. Exposed areas of the Portage Lake volcanic bedrock, especially with the veins, and the Native Americans exploited those areas. So again, it's extensive. You can just look at this real quick. The artifacts are found throughout the Great Lakes, the Prairie, Ontario, Minnesota, Wisconsin. They find some stuff even down the Mississippi River. This on the right-hand side are a compilation of radiocarbon dates and locations of them for old copper culture and old copper complex artifacts. Archaic era, I should maybe say. So the area around Lake Superior is the world's richest native copper deposits. And I want to specify, native copper is just meaning it's copper in metallic form. It's not an ore of copper. It doesn't mean Native American copper. It's just the geologic term for metal in the rock that's made of copper is native copper. So that just means it doesn't need much working, doesn't need to be smelted, doesn't need a complex process to turn it into an artifact. You just simply work it with a rock hammer and fire. And so that's very important. No smelting. There's no evidence for smelting in Lake Superior in the prehistoric time. Everything was worked with a rock hammer or some kind of copper chisel and fire. We do know that. So that's known as annealing, if you don't know. So there's all kinds of evidence for mining up there in all kinds of different forms. Today we went to the Caledonia Bluff area near Adventure Mine, and it's very extensive. I would argue most of these are prior to the woodland cultures, and I'll show you why. The woodland culture being the last 2,000 years. This evidence came in lots of different forms. Henry Schoolcraft drew this picture in 1855. They find these ladders in the pits, which were essentially there were central branches of, trees, trunks They cut off the branches to make ladders. And a couple people actually reported that. So there's ladders going into these pits. We have hammerstones. We have a fully formed copper industry. This is a mining industry. And other people have written about this too. Whittlesey, the guy that made the map, he drew some nice, beautiful cross sections of mine pits they'd found still intact before they were destroyed. And what I want to point out here is you can see there's a massive copper M on logs. They would jam logs underneath, pry it up, and move the masses out of the pit through just wedging. And here's a vein of copper. He kind of is showing with how it would have been exploited. The rock moved on the side, pushed up onto B, and that central vein, if you're looking at the side, would have been exploited. And what they find are things like that in there. Tons of them were found. This is one from Minong Ridge. It's like a 5,000-pound piece of copper. Notice it looks like it was beaten with rocks because it was. When they cleared out the Minong Ridge mine in the 1870s, they found pillars of copper in the ridge, and because they couldn't cut it out, so they would leave them. Hammerstones, found tons of those. We found one today. These are pictures, Isle Royal. That's a picture from Isle Royal, Minong Ridge I took. That's Seth de Pasquale. And these are the ones from Delaware Mine on the Keweenaw. There's some of them are evidence of hafting, which is the handle, like we mentioned. Other ones, strangely enough, especially on Isle Royal, no evidence for handles being put on them. So they were used just by holding. It's very, very strange. And thousands of artifacts have been found. I think just alone, maybe in this room, a lot of people are aware of this, but for the general public, hardly anyone is aware that there are thousands of copper artifacts being found around Lake Superior, still being found today. The oldest one is dated to 8,500 years ago, putting it among the world's oldest metal artifact. And this is from Vilas County, Wisconsin. So this rivals the age of metalworking in the Balkans and Asia Minor, Iraq, places like that. So we are definitely talking about one origin, at least, and maybe the oldest origin of metalworking technology in human societies in the world. These are some of the artifacts we've dated. You can see the dates on them. They're directly from pieces of wood in the artifact, not charcoal next to it, not a piece of string found in the same pit. They're literally the wood. So you can see the ages of how far they span. So why is it important to study this and bring this kind of information to the public? Well, as I mentioned, earliest metalworking tradition globally. This is helping us and archaeologists and scientists understand that foragers, hunter-gatherers, they can innovate. They're clearly created an industry. You need some degree of, I think, labor specialization at least part of the year. That's the beginnings of a complex society, moving into different specializations, not just hunting. But the weird thing is, we don't have agriculture. We don't even see ceramics. So metalworking precedes agriculture and ceramic technology, which in the old world, those are what we thought were necessary requirements for metallurgy to emerge. You need agriculture, surplus energy, specialists that work on the mining technology, people that they brought to mine, that they had to feed food. And then you have ceramics, because ceramics require heat to work them and to create ceramics. So it's a mastering of fire technology, and then that leads to metallurgy. In this case, skipped. So we need to correct this outdated thinking. We do not need agriculture for metallurgy to emerge. This is clear. That still doesn't answer all the questions. Now, when did this happen is what Bob had framed this beginning of the talk. It's been the question of when. One approach is radiocarbon dating artifacts. And from what I gathered, I wrote a paper on this. I was wondering, when did this happen? So I'm going to take all the radiocarbon dates I can find in the literature. And they are found in 4 key contexts. So radiocarbon dates are found with organic material in the artifacts, like sticks stuck in the spear, string around the spear. Cremations have been dated, so clearly an artifact was on somebody or placed on their remains, and they dated the cremation remains. A lot of that happened before NAGPRA. So nowadays it's tough to date anything associated with human remains. Sometimes they'll just find a piece of charcoal in the pit next to a copper artifact. which I call stratigraphic, and then mine infill. So on Isle Royal, there's all kinds of mines. They've been infilled and they took charcoal from the bottom of the pits. People put this stuff together in separate papers and journals across time. So I put it all together to try to look at it in a more coherent fashion. And there is some varying, confusing results. And Beber also tried to tackle this with one of her papers. Michelle Beber, you could check out in 2022. I looked into it and I found, okay, the dates spanned from 8,500 years ago to 3,000 calendar years, cal, BP, before present. Present is always defined as 1950 AD in science. So peak activity, 6,000 cal BP. And then it seems like around 3,000 years ago, this heavy copper tool technology fades away. It's a mystery why, 4,000 to 3,000 years ago. So when I synthesized all the dates, I found 53 old copper culture, old copper complex, archaic copper artifacts, dates. And I put them on a timeline, just plotted them up on a timeline in the groups they were found in. So all the dates, you can see them lined up stratigraphically, mines, cremations. Now these are all supposed to represent the same culture, complex. 9,000 years to 2,000 years, 7,000 years. So, and some of the groups, like the top ones, seem to be much younger than the ones at the bottom. So there's certainly issues going on with the radiocarbon dating. Which one seems correct then? Which one is we prefer to take as an estimate? The embedded dates are the actual spear, the wood found in the artifacts. Cremations, the context is preserved. We burn somebody with an artifact and we date the ashes and the context is there. But we don't really know. The mine dates seem to be much younger. The stratigraphically associated dates seem to be much younger as well. There's something going on here. We need something independent outside of the radiocarbon date artifacts to verify what's going on. What's going on with these young dates? You can even notice some of the mine pit dates literally date up to past 1950. You see 1950, the red dots? If you follow up there, the dates date to the period after historical mining collapsed. So that alone suggests to me there's an issue with those dates. So this is where my research came in. We need some kind of independent geochemical line of evidence. And one of those lines of evidence are lake sediment cores of all things in the world. Mud at the bottom of a lake. If you take the sediment core from there, you can actually reconstruct inputs to the lake over the Holocene, metal inputs, and it's strongly tied to mining activity. But jumping ahead a little bit, I'll get into that, just to show you what I'm talking about. I first published evidence of finding mining pollution in the lakes in the Keweenaw in 2013, and it showed that we can detect lead spikes and later copper that distinctly were human. They were way above background levels in the lake. So variability in the lake you can define, and then metals went way above. That was 8,000 to 6,000 years ago. So pretty old, and we'll look at that in comparison to the dates. But real quick, I don't want to get too much into the details, but if you're not familiar with lake sediment coring, just want to tell you a little bit about it. When we go core a lake, we're doing this. It's sticking a straw in the bottom of the lake, made of metal, putting your finger on it like you were pushing it into a slushy, and then you pull up the whole core. So you literally put a straw on, you put a vacuum, a plug on the top, and you could pull up an intact column of the mud at the bottom of the lake and all the layers in it. And so that stuff at the bottom of the lake is just organic matter, mineral matter, and things that flew in the air, like pollen, tephra, charcoal, and things like lead, metals.
What's tephra?
Tephra is volcanic ash. But in these lakes, we don't have that, but those are examples. So those three components in different proportions make up all lake sediments. And, very productive swampy lakes is a lot of organic matter. That's what we see in the lakes out here. Now, when you heat up metal ores, the weird thing is lead is associated with almost all metal ores. And lead has a very low melting temperature, much lower than copper. It's actually in the range of a wood fire. like 300 degrees C. And so when you heat up ore, what you're doing is you're creating a low pressure system in the fire. Anyone seen smoke rise? That means the pressure's low and it's rising into the air. And what that's doing is it's literally like launching cations all around you. Everywhere you're looking, they go up in the air and they settle down. It's almost invisible. You can clearly see smoke. You can't see these. There's conservation of mass. We can't destroy mass. We can't create it. So when you burn something, all those particulates go somewhere. And it turns out it's the landscape around you. Some of it's gas. By far, the emissions from wood fires are water and CO2. But there's a little bit of potassium, potash, it's a major cation, and then a bunch of trace metals. Now, if you're a lake and you're really, really low lead concentrations like around here, just small amounts of lead will be detectable from metalworking. Now, you might be wondering, how do you figure out the age of those layers, Dave? So we create these things called age depth models, and all they do is, see that black line in the middle? Those are radiocarbon dates as dots. So they tell us the age of the layer. Then that's a line we can then use a linear relationship. That's a polynomial line where we take the depth of the core, put in the equation, it gives you the age. You can kind of follow. So the depth down here tells you the age, depth. So we can create time series from these lake cores, very precisely, accurately dated with confidence intervals, time series of changing inputs of heavy metals to lakes across the Keweenaw, next to ancient mines through time. Essentially a little time machines. And we can then compare it to make sure we're getting accurate information. So we can first of all look at the historic period, 3 lakes, Copper Falls Lake, Lake Medora, Lake Manganese. We can compare what happened in the last 200 years and see if it's reliably recording what's happening around the lake. And sure enough, you see smelting in the Midwest begins in the 1700s with the French, and you see the beginnings of lead pollution. This is the upper Mississippi River Basin. The Michigan copper smelting period doesn't begin till after, I believe, around the Civil War. And in the Michigan copper period, you can see since the 1840s when the land was ceded from the Native American people here. And notice how quickly the lakes reacted to mining, immediately and accurately. And these are levels far outside the range of natural variability. There's no way you can chemically weather rocks around that lake to make that happen. Now, we take these same lakes cores and we just go back 9,000 years. That's over there. So you can see the modern has been cut off the y-axis because it's too high. And we just zoomed in and looked. So the 0 to 8,000 BP, notice, spikes the same way. And the radiocarbon dates at the top of the spikes. And here's some radiocarbon dates of copper artifacts. The only ones I was aware of in 2013, along with Encanto Cemetery, solidly in the Archaic. But weirdly, no evidence in the last 5,000 years for anything. Seems like this place was abandoned and overgrown, like what they kind of found, at least the mines, with the trees growing in them. So when I found these original 3 results, we were like, oh my gosh, because this is the first time pollution from metalworking in North America had been discovered at all. And the technique I had used had been actually developed to study Roman mining, Incan mining, and mining from the dynasties in China. So it was a well-established method using lake cores, extracting the lead to look for metalworking activity. It was just the first time it was applied here in the Michigan Copper District. So we had to, of course, expand. 3 sites, the craziest, oldest metalworking pollution we had ever discovered. So you can see the 3 original ones are down there. We expanded eventually after 10,000 years, and I went out to McCargo Cove on Isle Royal, a whole separate area. But we knew mines were draining into it. And we wrote a separate paper on this. Eventually I wrote that paper. Notice McCargo Cove at the top compared to the Keweenaw Peninsula. 6,000 years before present. And this is one of the biggest Native American mining districts we know about. And even the spike is bigger in the core. And we found additional dates, but it was still right around 6,000 years ago. This then we just kept going. We had a student. We got really excited about this. Kat Vall, she actually came and gave us a talk up here at one point. And just in 2022, in the journal The Anthropocene, we analyzed we put all the records together, expanded them all as far back as we could, almost 10 to 11,000 years if they had sediment. And in this lake, in Kat's paper, we specifically chose Lily Lake and Pond 2 because we know that those lakes are very isolated and there's no mining in their watershed at all. So if there's any lead signal in there, it had to have come from the air. There is no way. If you've seen Lily Lake, which you never would, it's a tiny, tiny little lake on a ridge, way away from everything else. And so we found in those sites, as we see over here, if we're looking at all the lakes, so now we compiled all of them together. Notice it goes all the way back to 11,000 years, and these are all what I call the human lead spikes. Lily Lake and Pond 2 are here. Here's McCargill Cove, and then this is all the Keweenaw. So all these sites, and this is moving from the northernmost site to the southernmost site, just looking at just the lead. And sure enough, Lily Lake and Pond 2, analyzed in a whole separate lab, independent from these other ones, show again these anomalous lead spikes dated to 6,000 years ago. And there's no connection between any of these lakes. They are all separate. You can see they're miles apart. And to have those spikes go so far above the natural background variability points towards something anomalous. Anomalous on the level of ancient mining, meteorite impact, supervolcano we don't know about, something like that to make those lead spikes. And so without any evidence for a supervolcano, without any evidence for a meteorite impact, which actually if it was a supervolcano or a meteorite impact, we'd probably see them all at the same time, at all the lakes, because it would have been regional. But you notice there's patterns in each lake. They're each unique. They each record a regional metalworking signal. Notice Boston Lake at the southern Keweenaw, the bottom, only records one distinct increase in lead over 11,000 years. Whereas if we go to the northern Keweenaw and Lake Manganese, look how many events we see, 4. So it shows there's regional variability in the metalworking as well. And we can't explain it all by runoff. Some of them, like McCargill Cove, we can definitely explain as runoff. But what we've found, at least with Lily Lake and Pond 2, which are these very isolated lakes, not near any of the copper mines, that if there is lead in Lily Lake, it had to have been blown in. So we have metalworking, we have mining, we have metal pollution in lakes, and they are happening at discrete time periods that are happening 6,000 to 9,500 years ago. We are now implying like emergence of cultures. Each one of those spikes are, by the way, are a century or 2 centuries long, even though they look tiny. That's about as long as a mining history we have here today, 1 to 2 centuries before it seems to fall off. Mystery. And just real quick, which I don't understand fully, but using all the radiocarbon dates that we've gathered, including mine, Weber put together using this OLE model that 10,000 years must have been the origin of metalworking. And again, that's consistent with what we're seeing in the lakes. So we're seeing spikes beginning 9,500 years ago in the lakes, that those anomalous lead spikes must have been caused by something producing lead dust in the air, which there aren't many natural processes that do that. Now, if the lead pollution is right, and we have the dates, our timing for this metalworking industry must have been the archaic. So before 5,000 years, 6,000 years, roughly speaking, with error. So we know from the lithics, these were mobile, we thought, egalitarian hunter-gatherers. There wasn't much social differentiation in the cultural remains left behind by these people. We don't find any settlements. We don't really even find any graves. But there must have been a rich technological culture, obviously, an innovative culture that plans to conduct these huge operations. And we know that the copper was used for everyday tasks, where in almost all these ancient societies around the world, metal at the very beginning was always such a specialized material that it was almost always used for symbolic or religious purposes. And again, in this case, in the old copper culture, it's opposite. Everything is utilitarian. It's used for everyday life. So again, makes it so much more anomalous in world history, with metalworking being a regular part of life with cultures out here 8,000 years ago. Nowhere else in the world would that have been happening. If you talk to an archaeologist that works in Bronze Age Europe, which I actually personally have, if they find one copper or bronze artifact at a site, professionally excavated, they call that a copper or metal-rich archaeological site. We have people here in the Keweenaw that find that in their backyards. Easily, multiple pieces. When during the Father's Day flood, you heard lots of stuff was eroded out of the banks and the creeks around here. So it's on a scale that we're severely underestimating, all of us. It was huge, and it went on for a long time. But by 3,000 years ago, that style of tool becomes rarer. Now, what's going on? We don't really, there was speculation in my book. I cover some of the reasons for this. Maybe some of the stone tools were actually better for some things than others. There could have been environmental changes in the culture for other reasons, war, droughts, etc. Now, as Bob was saying, almost all woodworking, hunting related tech, not much symbolic stuff, and things were always annealed. So this pollution is some of the earliest evidence for controlled use of fire for metallurgy. The old copper culture predates almost all the metalworking societies of the so-called old world we talk about. It's older than the old world. And again, it shows that our models of human society and development don't always follow agriculture. And because it's so old, it predates almost all of the kind of myths and stories that were spread around here, that you could have been the Vikings, could have been the Phoenicians that have been here, an unknown journey of some kind of European group. But what our dates are showing is this is thousands of years before anything in Europe was happening. Way before the Vikings, that's 1,000 years ago. Phoenicians, 2,000 years ago. We're talking dates 8,500 years ago. Thousands of years before the Giza pyramids. And I believe that this lack of awareness led to all these conspiracies about where they came from, led to all this speculation, and put these stories forth that you find on the internet and Graham Hancock. And I think the reason for this is because what we're stuck with the old copper complex is between two extremes. And we have the overly sensitive, conservative archaeologists who won't say anything, except copper was worked in the Keweenaw Peninsula for thousands of years, as I've seen in a million brochures. They act like there's no history to learn. It was pecked at and worked at and this and that, and they made things and left, and they don't give you any story. And then you have the outlandish pseudo-archaeologists who just say it's the Vikings or the Phoenicians and all this stuff. And there's nobody in between trying to bridge the gap. And so what I saw with the book was it was time to build a serious narrative that honors the true history of the Native Americans. And so that's where I wrote the book Great Water, tried to give context to what we found in an engaging way. So it's as a novel. It's very easy to read. You can be 5th grade to read it. And it's a book based on true events, weaving together a fictional and nonfiction plot line to tell this story in an easier way. And it combines all kinds of different approaches together, evidence from archaeology, geological, cultural perspectives, all to, try to get it so many different ways. We want to look at the boating technology, we want to look at the cooking technology, and everything that goes along with the old copper culture. And I built the whole book based on my field research out in Isle Royale in the Keweenaw. I walked across Isle Royale a couple times now from the whole island, and I've been coming up to the Keweenaw for 15 years, and I've seen ancient mines all throughout the Keweenaw and up on Isle Royale. And so that was a huge inspiration for some of the fictional chapters and things like that in the book, just to make the scenes come alive. And so, some of the characters are fictional. I actually tried to create an ancient copper mining society, being as respectful as I could to the history of Native Americans, but we had to create characters, the ancient miners, and what they must have went through paddling out to Isle Royale to create these mine pits. And so Great Water, it refers to the indigenous word for Lake Superior, Gitchigami, and Gitchigami is a big water, superior water. And what I liked about the whole title was it's both literal and metaphorical. We're talking Great Water, so it's like deep history. It was very geographically extensive and spanned many cultures. So Gitchigami, Great Water, is the kind of the inspiration for the book, the title. And I want to emphasize, like with the book and overall, this whole culture and this issue of bridging the gap between overly sensitive archaeologists and these wild pseudo-archaeologists is what we're trying to do, and Bob and I and other people studying this, is the OCC, in a way, it is a mystery, but maybe it's not a mystery to be solved. It's more of that we're kind of uncovering the heritage and the history here. And what we're trying to do is make sure that we recognize it as the data that's coming out, and we do it in a respectful way. I want to emphasize, we're not necessarily uncovering this unknown mystery to everyone that's lived on Earth. There's a lot of indigenous people have stories and oral histories that go back in time, but I think what we need to do is clear away all the distractions and uncover that heritage that is here. It's thousands of years, so that we can reframe this and understand it in a more accurate way and not have to worry about coming up with stories from ancient Europe and coming here to mine the copper. And so the old copper culture overall, it's just revising, it's forcing us to rethink so much about world history, civilization overall. It's kind of turning world history on its head. We don't need agriculture to make specialized societies. Metalworking can jump ahead of all these other markers of social complexity and then fade away without developing fully into a smelting technologies like we saw in Europe when we moved from the copper to bronze to iron. Where here, it just seems to have stopped at copper working. And this is all, revising how we're thinking about hunter-gatherers that lived in the Keweenaw 8,000, 6,000 years ago. How complex were those societies? How many people really lived here? Was it much bigger, the scale, than we actually think? Was it more than just people, on their spare time after they've hunted, going up and getting some copper, on a few-day outing? Or was it more specialized? I think it was more specialized. And I think it varied through time. It wasn't Native Americans worked copper in the Keweenaw on and off for thousands of years. It seems that there were discrete periods where the activity intensified, and it led to emissions that were above background levels in lakes and then declined. And so it seems like it went away, and then eventually some other group moved in and it grew again and went away, and it seems to happen for thousands and thousands of years until mysteriously 5,000 years ago that stops, until modern technology, modern industry, really iron technology and fossil fuels unlocked the copper that was deeper in the rocks. Essentially, the archaic people had scoured all the surface and they got all the copper down 10 feet that you could obtain with stone tools in manpower. You needed new technologies to unlock the rest, and really it was iron. So there's implications for archaeology here. These lake sediments, like I showed you, they represent a brand new window. We're looking into a new window. You just looked into a new window into the past. It's not relegated to just artifacts. That's what you really have to understand about this. Artifacts are one window to look at the past. Lake sediments are an independent window, and we looked at just one proxy, lead. We are developing DNA, fecal stanols, that all can be isolated from these lake sediments. In theory, we could maybe find DNA from an ancient miner one day in one of these lakes. So lake sediments represent a huge untapped potential. Michigan copper districts. I'm now on to new projects in the Pacific, and I haven't been able to work out here. But I think what this is encouraging is these interdisciplinary approaches. We need to combine different lines of evidence. LiDAR is an interesting one that's coming out too. And maybe some people are aware of that paper of looking at the maize fields near Escanaba. What's the rivers called again? Menominee. That's another avenue of interesting research that can be done. We need more lake cores though. If we had some students here that are interested in this, those are the lake reconstructions we have. We could get more dates. We especially need more control sites, actually. We need to find more sites with no signal, which we have a little bit, but we definitely need to expand on, because we need to see where geographically the patterns of this lead, where do they fade away? Where can we detect them? Is the southern near Rockland part of the Keweenaw, does it even have a signal? Is it at a different time? Is it in the late woodland? Is it the missing 5,000 years? Is that found somewhere else? Michipicoten, we have not studied there. So there's plenty of room for expansion. Just want to remind everyone, the OCC is not a footnote. It's not this minor blip in the brochure with one line between the lighthouse history and the Edison fishery with one line for the old copper industry on Isle Royal. This is one of the biggest stories in world civilization history. This is thousands of years, the oldest metalworking. It preceded agriculture. It's on a scale in the ancient times, geographically, temporally, gigantic. I think the scale, we are severely underestimating the scale. And so the book is trying again to tell this story in that way, that it's not just a footnote, it's a huge part of the history of human societies. And so you can check it out. If you scan that, you can look it up. There's an Audible book, we have paper books online, includes a bunch of citations, maps, and suggested reading in the book. That is it for me. I'll take any questions you have, if you have any. I think to leave, the last thing I want to note is, when did the mine pits happen? My research has noted, my opinion would be between 5,000 and 9,500 years ago would be when they were created. That doesn't mean people didn't use copper in the Keweenaw for the whole 10,000 years, but the scale and degree of metalworking varied through time. That's the key. And it went up in intensity for whatever reason. Culturally, a genius showed up on the Keweenaw, a mining engineer genius, organized everyone to figure it out. We don't really know, but it's certainly changed in intensity through time. In the most intense periods of detectable metalworking pollution from 5,000 to 9,500 years ago. And that's it. Thank you. Hello, everyone. I'm currently taking a walk through Bluff State Park along the shores of Lake Erie, and I want to take a moment to ask you to check out my book, Great Water in the Lost Mines of Lake Superior, if you're interested in this subject. And if you don't want to buy the book, like the video or subscribe to my channel to support science communication. Thank you.
Agriculture follows and
Yeah.
presupposes all these other developments. What framing then are you promote with?
Oh, yeah. Thank you.
Historical materialist.
Oh my gosh, I love that. Thank you so much for that question, because there's a lot of stuff I wanted to get into, but what I'm thinking is, this is a hunter-gatherer society before agriculture, but we still have a massive energy issue. How do you feed all these people if they're mining without agriculture? That's really the issue. And so what I propose in the book, and maybe I'll write one day, is I think there is a lake resource foundation for the industry. So they survived off of fishing. And I think the copper technology was critical for fishing. And therefore, and that came specifically down with hooks. Hook technology made with metal is vast superior to bone, wood, anything you can make with shell. So if you have hooks, you live on Lake Superior, and you live on an icy lake, you now have accessed all the food below the ice, deep in the water. You could drop a hook down. And so that hook technology was critical, I believe. And that, once they realized the hooks allowed them to fish deep water in a new way, that allowed more fish to be gathered, more people to grow, more demand for copper. And then the reason for getting the copper was to exploit the lake.
So you really are pushing for more of a materials outlook, saying they had this resource there, and that's where it ended up driving more. I
think, yeah, I'm a geologist technically, so I'm not trained in archaeology and the theories, but I think that's what I'd be arguing, yeah, is that I think there's all this work done by Michel Beber showing copper spearheads, copper knives. They're not much better than stone. They're the same. They're the same functional thing. So Beber puts forth the speculation, like, well, then why would they mine copper if stone is fine? Why put all the effort into metal when your spearhead made of metal is no better than a spearhead made of rock? But I think what she's missing is the hook idea. Metals make better hooks. They're malleable. That's one thing copper property had that the archaic people never experienced before, is malleability. They could shape it and bend it and turn it into hooks, whereas stone has no malleability. It cracks. And so that malleability allowed for superior hooks. I think, yeah, then the material aspect of having a malleable hook and being able to make it, I think led to fishing revolution.
I should clarify, my use of material is more of the philosophical development.
Okay.
Like the split between idealism and materialism.
Yeah.
Aspect of it, which I guess is appetizing. But that still makes sense of like, the resource was there, so it would have driven
right.
that other culture around what was available.
Yes. And just as a contrast to be extreme, like, imagine that copper was just symbolic. So they just wanted hooks because it's valuable to have a hook, and then keep it, it's sacred. And like, kind of like the contact Native Americans here had copper, but they looked at it as a sacred thing. It was to be cherished, it was handed down. They didn't use it for fishing in the lake. But yeah, so if you just were using it as pure symbology, imagine all the effort into getting the copper just to look at it. I just don't think, and especially if you have an archaic hunter-gatherer society with very low social complexity, you don't need to show off. There's nobody way up higher than you. Materially, there could be lots of, yeah, okay. And I'd like to talk to you if you want to ask any more questions, but if you want to get into it more. But I think that would be my feeling, is there was a really strong reason for the material to be obtained, especially in a regular supply. It wasn't randomly found in creeks. They needed regular supply of copper for some reason. And if it's not a superior spear point, it's not a superior knife to stone, then what's the reason? We could all in here come up with reasons, and I think that's what it was, the fishing. I saw one other question. So the oldest dates from the Keweenaw, though, are from this site called 20 KE20, which Susan Martin worked on, and it's a stratigraphically associated date. Like I mentioned, it's just a date found in a pit that was old next to the date. You saw the patterns. The stratigraphically associated dates are way younger, except for one. And that's that one, I don't want to pull it up, but there's one anomaly from the stratigraphic associated, that's the Keweenaw. And it's like 9,000 years old. And it's 20 KE20. I believe it's near Lac La Belle. Mm-hmm. And behind you? Yeah.
So, this date's being 9,000 years old. That's not too long after the glaciers receded. That's like pretty darn
yeah.
right away.
Yeah. You're right. We think that they trailed the ice following megafauna. And yeah, the ground's bare, the copper's exposed. They heat it, they realize it has a different property. You can shape it into, bend it, turn it into weird stuff. And another thing is there's very little lithic material here that's good for making spearheads. So you would take the only thing you could make a spearhead with, if you wanted to make an atlatl spearhead, you'd use the copper. This is the idea of, it's a lithic poor area here. Isle Royale and Keweenaw don't have good rocks for making arrowheads or spearheads. So if you don't have a good rock to make a spearhead, copper's going to be pretty good. And like you said, yes, I think it came right after the deglaciation. With my research, I've dated it on the Keweenaw and Isle Royale using the lake sediment course. So when the lake sediments start filling up, it's 12,000 years ago. In the oldest sites, about late 11,000 to 12,000 years ago. First evidence for metal pollution is 9,500 years ago. So we're still talking 3,000 years of history. So it's hard for us to scale all this because we think about our history since AD, BC type stuff, which is the last 2,000 years.
Can I address that?
Yeah, go ahead.
Mostly knackable stone, but also stone they could make groundstone tools from. And in those gravels, they also found copper. And over time, they figured out how to fashion the tools. That probably wasn't a quick thing. They had to work it for a while, but they had time. And then they followed the glaciers as they came north, as they retreated, looking through all the glacial outwash, and as they came further north, they found more and more copper. Being heavy, it's not going as far as some of the lighter rock. So, and they followed it up until they finally found it sticking in the ground still. I think we'll find in the long run that the first use was way south.
And there's other evidence for early people in the Upper Peninsula now too. They found obsidian from like Yellowstone and Lake Huron. That's 9,000 years old. And there's some old Paleo-Indian spearheads. Just like 20 years ago, we had no evidence for people up here before the Archaic. I mean, I think, yeah, like 20 or 30 years ago now, early 90s. So now we know people were up here right after the ice.
So you talked about the opportunity for different disciplines to come together. Are there anthropologists piecing this together? Is that one of these opportunities? Is there a university doing it?
You're looking at the person.
Is nothing left besides the copper, the sediment, and you?
Michelle Beber at Kent State's done some experimental stuff, with the functional efficiency. But she's an archaeologist she just does experiments of different technologies. So she's published stuff recently. And Mark Hill a bit at Ball State. And Tim Scarlett's been here at Tech, has been on the fringes, but he's mainly a recent person. So yeah, it's pretty much me. Sorry.
At Archaeological Field School working at Delaware. A couple years ago, they did a dig on the ancient pits. Now, last year and this year, they're just doing digs on the historic sites. But hopefully they'll go back to some of the ancient. Those 3 fissures in Delaware line and open one of those again.
Yep.
Through all of your research and expertise, is there any information on the percentage or the density of copper on Isle Royale compared to the Keweenaw Peninsula? The eye field are one and the same.
I think, yeah,
The volcano was Isle Royale.
Right.
And they erupted, right? And then when the glaciers were brought to Mississippi.
Right. Well, yeah, but it pushed it south. Yeah, I think, the rocks that are exposed in Isle Royale are part of the same syncline as the Keweenaw. So it is the same rock.
Right, it's the same.
But there's certain layers within the stratigraphy that are more rich in native copper veins.
Right.
Which is what it seems like they targeted along with the drift deposits. Like there's no evidence I'm aware of that they targeted conglomerates or the migdaloidal deposits. Yeah, and definitely not the sulfides, which they did even later in the industry recently, historically, because that's even a lower quality. It has to be smelted. So yeah, they looked for, I think it was the same. Short answer, yeah, same.
You made a good point on, the different viewpoints on how to actually address it, between the conservative archaeology,
Yeah.
especially in like the United States policy on either purposely obscuring or outlawing sculptures and, at least that opening up, but still being treated as if it's a thing of the past, which would lean more into the lack of seriousness that's been put on, like especially as advanced as that culture would have been.
Right. You're really good. I mean, you are really good. Because I was talking to Bob and Dane about this exact thing, and the technique I developed, I used here was developed for Roman study. The Cord Lakes next to it. Here's a Roman mine. It looks like an ancient copper mine, first of all, when you see one. And they cored, my colleagues cored lakes in Spain next to these mines. The spikes look exactly the same as the Roman, except it's dated to 200 AD, 100 AD. Not one person has ever said, I don't think that's a Roman spike. I think that might be from a meteorite when it's dated to 100 AD and it's next to a Roman mine. The amount of doubt from what could happen up here, it's unbelievable. Even the people that are co-authors of my paper still to this day don't believe it. And it's because, like you said, I don't know if it is implicit bias that we are, without even consciously knowing it, we put Native Americans down. even though we recognize it, we just can't grasp that somebody 8,000 years ago, especially Native Americans, could leave a lead signal in a lake. We just can't grasp it. And it's really weird. I do not exactly fully know why. I think it's part of the history of the U.S. I think it's part of the neglect in public education on the Native American history. It's the reason I kind of wrote the book, is to make it approachable and to integrate it as a story. I look at it more like an expansion of U.S. geographic history, the geographic U.S., not the political U.S. in Canada. We stop our history like at the signing of the Declaration of Independence, and we know a little bit about the Sioux Wars and the Comanche and all the horrible things that happened to them. But it's like history only begins at the signing of the Declaration of Independence. I want to see it seamless. And I don't want it to be like U.S. history starts at 1776. U.S. history keeps going as a geographic entity. We just need to make it continuous. The history just keep building it back and creating more knowledge so that it is taken seriously, looked at that way. So anyway, great question. And another one?
Like spear points, knives, and like fish hooks, has there been any kind of like correlation between like some of like the dates we have that are associated with those artifacts and just like the farms, just to try to find like different like cultures that might have, 8,000 years ago they might have been making stuff totally different from stuff 6,000 years ago.
Right.
Because that's this huge time span. Hunting different things, fishing different things.
Yeah.
Do we have any of that?
What it would come from would be we see more variability in the stone tools. So stone tools change a lot over the time. The heavy copper tools, there is some pattern. They do kind of resemble big spearheads at first, and they kind of get smaller, but there's nothing distinct. And Bob, you can add on to this. There does seem to be variability in copper technology over that time, but it's hard to do systematic review of it because we need dates on all of them to find out which ones are exactly the oldest, which ones are the youngest. But overall, they just have this heavy copper tool look. They're just big old copper tools. And that's the best classification I've heard to describe it. Because if you see the woodland, like, Cahokia, the big city by St. Louis, you look at their copper artifacts, they're pounded, birds and ornamental, and they would wear them on crowns, the copper, or they would plate a wooden thing so that the outer part of the staff the chief is holding, along with their crown, is copper. And it's thin, and they're very super advanced. It's so weird too, the copper artifacts become rarer, but the technique becomes exponentially more advanced. They become making these just unbelievably intricate copper artifacts. I don't know how else to explain. I don't have the words for it. But they're essentially crowns the chiefs would wear. That's part of it, I think. But yeah, so the copper artifacts become rare. Also at the same time, we find no metalworking evidence. I didn't tie that in. So once we see the pollution go away, if you remember it 5,000 years ago, soon thereafter, 4,000 to 3,000 years ago, there's a technological shift in copper. The heavy copper tools go away. There's no mining. Part of that impetus. It went from being a common everyday item that you could go up to the river and trade for to an extremely rare, expensive item. And so that, my guess. Any other questions, thoughts? Yeah?
Isn't there a large open pit copper mine on the other side of the world? I'm thinking Argentina or Brazil.
Probably, I'm not sure though.
I just have thought that.
Yeah, there's, one.
Versus the deep shaft mining.
Yeah, there's pit mines. I've thought about maybe, Montana Butte has a big open pit lead mine. I wonder if that's a galena deposit. Native Americans might have been using galena. Yeah, but I don't know.
All the present mines are ore, so they get a ton of rock and
Right,
you can't see the copper in there. But they get it out, used to be they melt it out, now it's chemical that they get it out with. But this was native pure copper.
Right.
And no one else, that has you didn't need to refine it. So that's definitely unique in the world. I think, Otzi the Iceman in Italy, he found on the glacier or up on the mountains, he had a copper axe and that was smelted. He's dated to 5,000 years ago. So I think even the Italian, that was smelted, cast. And even they, in 5,000 years ago in Italy, were smelting copper ore. They find the first evidence for smelting in Europe and in the Balkans and Serbia in like this about 6,000 years ago. It's the first evidence for slag, well dated.
But there was the Chalcolithic age.
Yeah, the Copper Age.
So there was some native copper.
Yeah, definitely. Some was found. And gold, native gold. There's two metals really found in native form, gold and copper. And I think silver too. Yeah, silver is found pretty commonly. But almost all of the metals are combined with like a sulfur or some kind of other thing that has to be blown off. Yeah. So they were definitely part of the copper artifacts here too. You find the silver nodules. But as far as I'm aware, I don't know if they found any pure silver artifacts made like, I've never heard anything.
Especially from like more economic development, like Britain having to deal with the Shah introducing gold into their system. But that's more of a probably like contemporary way to look at it instead of more of an ancient culture development.
The Lakes Killarney area of Europe in Ireland is probably the oldest mining, I think, in Europe. And it's pre-Roman mines in southern Ireland on the shores of Lake Killarney. And the pictures of the pits look so much, I'm not trying to make a connection with the old world. I hope no one's going to quote that. But they look so similar. But to me, that just suggests they're really old. That's what I'm trying to say. Pre-Roman, so across Western Europe, metalworking went up a notch when the Romans showed up. They wanted gold for the empire, for their coins, for their emperor. And so they show up in Spain and ramp up metalworking that the indigenous Spanish were doing. They ramped it up across England. So when you hear pre-Roman, it's like a buzzword, like, holy crap, that's old in Europe. Because everything is dated to Roman. Like my colleagues that work in Spain, they're all, the signal they find is Roman. And so even the people before that didn't produce enough activity to change the lake composition. And you know, this is another thing to keep in mind. Now imagine you found a lead spike 180 in Spanish, but you did not know about the Romans. No idea. When you look at that lead spike on that graph, you have to imagine the Roman Empire and how it spread and changed religions and slaves and wars, and it emerged out of Rome to spread across Europe over centuries from one little lead spike. But luckily we have records and history to fill it in. On the Keweenaw, we have none of that. We see a lead spike here. That book is the best attempt at trying to fill in the details of putting a story together of what actually would have happened for these lead spikes to show up. There had to have been a degree of organization. There had to have been some sort of degree of planning, and just things, economic demand, the fishhook idea. We don't know exactly what the demand for the copper was, especially if it's not better than a rock spearhead. So why did it have a demand? To explain the Spanish peak, you'd have to know about the Roman culture and the denarius, or the coin they made, and you'd have to know that the coin was used all across the Mediterranean. It was the global currency. And they paid their soldiers in it, and they conquered all so many things just to come up with the reason for that spike in the lake. Here we just we're doing it from the best we can, and while honoring the fact that I know and we recognize that they are the ancestors of the Native Americans, but we're talking thousands of years ago, so we have to use our imaginations, I think, to some degree, and put a little bit of founded speculation in there. Yeah.
Are the scale of the Roman spikes the same, like
Pretty close. It's
in Europe pre-Roman that has that same.
Greek. There's some ancient Greek signals, but yeah, the big signal, it's the Romans. Then there's the Dark Ages, and it's not till 1600s. With the advent of the Industrial Revolution and the Enlightenment that mining comes back on a degree big enough to leave records in lakes. The whole medieval time, the Dark Ages of Europe, a lot of the lakes don't have any lead pollution in them like we see here, because the economy collapses, the demand for the Roman coin goes away, because it's basically, they printed their money out of existence by cutting the coin with copper and other crappy metals. So you have to then explain the collapse of the Roman Empire and why it collapsed. So yeah, there's just so much in there that, the Greek is the only one. We don't find any Egyptian. We find old stuff in the dynasties of China, the Tiwanaku and the Incan. The dynasties of China last 3,000 years. Tiwanaku and the Inca last 1,000 years. Roman time lasts 2,000 years. So that shows you how this is so much and so anomalous outside of world history. We're talking 9,000 to 5,000. So older than everything else. And it begins and ends before everything else. And it's anomalous like a Roman lead spike from a Roman mine. So if you're thinking, when you go home, think about that and you realize we're missing the scale. Like we are severely underestimating. This thing was huge. And the people, another thing, 8,000 years ago, the people here would have so much metal, they would have been, no one else in the world would have been like them. They would have been carrying spears, hooks, bracelets, in an entire world where no one had metal. Again, another thing that I think we're just overlooking as a history of our geography here. Yep, I hope you're inspired to sort of learn about ancient history, and maybe if you're in school, anyone in school here, by the way? No school people? All right. Well, if you were, I was going to say, take it on as your PhD. Anything? Rob, you got anything? This is the field crew original in 2010 for the first cores. And there they are. Those are the people that did it. That's standing at Copper Falls Lake on the Portage Lake Volcanic. But thank you everyone for coming. I really appreciate you coming out. I hope you were inspired. Thank you.